you can get it. Okay, cool. Here we go. Recording is up and running. So, again, happy Tuesday, everybody. Let's get this party started so we can get through unit 12. Yeah, 12 or 13. Sorry, my brain is a little wonky right now. So, Spirit Week number 2 this week, VHS Virtual Spirit Week. Yesterday was Mellow Monday. I missed the opportunity to pick up myself in my favorite PJs. It's all good. It's just sweatpants. So, cool. Today is TikTok Tuesday. I don't have a TikTok, so obviously I will not be participating in that one. But I've seen a lot of TikToks. My brother's been showing them to me regularly, so I know how funny they could be. Plus, I know I've seen a lot of those over time. Wednesday, Wilderness Wednesday. That's tomorrow. Post a pic of yourself outdoors. Remember, do so responsibly. But also, this is not me telling you to go out and associate with people outside, but make sure you try to get outside every now and then. It's good for your mental health. So tomorrow is Wilderness Wednesday. Throwback Thursday, post a pic of your favorite throwback school pic. I'll put a couple up that I can find. Lost most of my high school pics because of old phones, but try to find a few. And then Feel Good Friday. Always try to do that. But nonetheless, let's get this party started. Announcements here. One, first and foremost, I don't know if it's frozen on your screens, but it was frozen on mine. So let me try to restart this. I don't know why my iPad does that, but it does. Okay. I want to just say keep up the good work. I did progress report grades yesterday, and specifically to your subject, Algebra 2 Trig, periods 1 and 2, I had 0 Fs or 0 Ds in there. Everyone with a C or above, y'all are crushing it, okay? So, like, seriously, really good job. Keep up the good work. And we only have 5 weeks left until summer. This has been a crazy school year. I know you don't need me to tell you that. So it's almost done. We're almost at that finish line. We'll talk a little bit more about the expectations in just 1 second. But you're doing great. Couldn't be more proud of you as your teacher. It's been a crazy first year for me teaching at Valencia, and I'm pretty excited about your guys' work ethic and ability to push through this. So that's number one. Just great positivity out of y'all, and you're really bringing a smile to my face when I'm going through and grading that stuff, seeing all the work that you're doing. All right. Remote learning agenda, RLQs. I want to specifically spend a little bit more time today on the announcement number 2 here. The remote learning agenda, we talk about it every week. I just want to continue to stress that it's here for pacing and purpose. I have it zoomed in basically now on the latter half or the bottom half of this agenda because we're now down here on lesson 5. There's a unit circle ed puzzle that was posted last week on the Google Classroom. I mentioned you didn't have to start it because we hadn't talked about the effective lesson yet today, as we will today. But it's up and running. I changed the title, so please start trying to do that. More to come on the ed puzzles in a second. Notice that today, when we get around to it, after all the announcements, we will be doing this assignment together in class. Sweet. And we'll be doing those problems over on the right. I specifically am showing you this not just for repetition of it, but rather to focus on the bottom portions, projects. Effectively, what it comes down to is we have a couple of projects coming up. They're not, don't stress about them. The logs project is going to be a partner project if you want it to be, and the final portfolio project is going to be something where you have the option to choose how you want to show me you know what you're doing, meaning you could do a little write-up, you can create your own Kahoot, you can create your own slideshow. It's going to be super open-ended and super low stakes in the sense that you are going to basically dictate how you want to do the final through that portfolio project. We'll talk more about that in a couple weeks, okay? So just a heads up on the big things coming up. Partner log project, portfolio project, and that will be up to you. So really, we are trending down through the final part of our class. So that is our remote learning agenda. Sweet. RLQ, y'all might know this as the remote learning questionnaire. I've been getting some good questions on those. I've been trying to respond to those as often as I can through email or through videos, but I specifically want to highlight this week's RLQ because I want you, if you haven't already filled one out, these are what they look like. I've adjusted the second question and added the third question on there. So typically, like the first question you see here, please describe your question or problems you would like to discuss. That's the same. Now I just wanted to get a little feedback on how we're feeling. And you can interpret the second question, how are you feeling, in a variety of ways, maybe in an individual level, like how are you feeling as a human or as a person? You could tell me if you're feeling good, bad, stressed, let me know what's going on. I won't share any of this information with anyone. This is just so I know how you're doing and I can try to help you as best as I can. And also, you can roll that into question number 3. How is this learning process going? Do you have any recommendations? Do you feel like, I know it's difficult, but do you feel like that this has been a receptive and open and clear process on my end? Do you know what's expected of you? I know it's hard to learn math online. I'm very aware of that. So anything that you could give me that I could try to mold this class around for the next month to make this last 5 weeks really, really successful for y'all, I would love to hear that and incorporate that feedback into this class. So please fill that out if you so desire, if you want to provide any feedback or input for me. And yeah, that's try to fill that out. It's always up on our classroom, on the stream. I try to post it basically on every single Zoom session and all the weekend, meaning like on Friday or Saturday when I post those videos, and on Monday when I post those videos, I try to put those up there for y'all. All right, cool. Ed Puzzles, we already talked about it. Keep on keeping on. You guys are doing great. Another one got posted last week. Feel free to finish it. Quizzes. Don't forget to complete the trig quizzes. It's in lieu, meaning in place of assignment number 2. I've seen about 20 of them in so far. Solid work. Keep filling those out. A new quizzes is going to be posted on Thursday. It's called the Unit Circle. It's not a mandatory assignment. It will be extra credit if you score above 75% on it. You can turn it in multiple times if you want to. Not mandatory, extra credit above 75%. Right on. And Zoom sessions on Fridays. Those are our office hours. Hopefully I'll see you all there if you need any help on anything or just want to stop by and say hello. All right, cool. Does anyone have any questions, comments, concerns, anything that y'all want to say before I move forward into today's lesson on lesson 5, the unit circle? If you do, unmute yourself or tap it in the chat. I'd be happy to address those at this moment. Sweet. Okay, so yeah, if anything ever pops up, y'all know, never hesitate to stop me. All right, okay. What are we doing today? We are continuing our journey through the circular motion of angles, the unit circle now. We talked last week about degrees and radian measures. Degrees were the displacement of an angle, how far that angle's initial and terminal side are moving, those rays, as we learn about them in geometry. And then we doubled down and realized that if you move in a circular motion like the hands of a clock, theoretically distance is being moved around the outside of the circle, and we define those or describe those in terms of the word radian. So what we're really going to do is we're going to take all of last week's content and now combine that with our knowledge of special right triangles that we've heard in previous math classes to really understand these coordinates and completely finish the unit circle. So we're going to do so in 3 ways. We're going to define a few words on page S5. We're going to just do some connection notes, which I want to stress are a separate PowerPoint that I uploaded last week. I'll show you where to find those. And then we're going to do the lesson 5 homework together in class today. Okay, so that's where we're trending. Let's get it going. Boom. Okay, vocab, page S5, loading now. Sweet. Okay, so the 4 words, 4 phrases I specifically want to focus on are the unit circle. We've actually talked about this kind of ad nauseum a lot up until this point over the last week and a half. The unit circle is called a unit circle because its radius is 1 unit. Okay, 1 mile, 1 inch, 1 foot. It does not matter. It's 1 distance across. And we can kind of apply that to a more than singular unit as we continue to perfect our knowledge of it. But for right now, we are talking about all these angles and radians in reference to a unit circle. And again, it is called a unit circle because its radius is 1 or 1 unit, a singular motion, use of the word there, unit, not unit. All right, quadrantal angles, said that really weird. But the word quadrantal angles builds off that word quadrant, and quadrant is built off the root quad, and quad means 4. So when we think of quadrants in a graphing scenario, what we're really basically saying is the y-axis and the x-axis make 1, 2, 3, 4 quadrants. I'm sure we learned that back in pre-algebra. We got good at defining what quadrant 1 is, quadrant 2, saw the pluses and minuses of the coordinates, the x and y values at that point. The quadrantal angles are the big 4 angles that we started with defining last week: a 90-degree angle, a 180-degree angle, a 270-degree angle, 3/4 of the way around, and a 360-degree angle, a full revolution. So the quadrantal angles are the big 4 angles that create the x's and the y axes. And therefore, from those quadrants, we created all these other smaller angles, which we referred to last week as reference angles. And today we're going to figure out how all of these angles create pairs through our use of special right triangles. And those special right triangles, as we learned them in most likely geometry, a few maybe kind of got introduced to them in algebra 1 and pre-algebra, depending on our text that we were using. But special right triangles are these 30, 60, 90 right triangles and the 45, 45, 90 right triangles. Now, I'm not forcing the memorization of those ratios, the comparisons by division, aka fractions, but we're going to see how those create those ordered pairs that turn into the Mondo unit circle that we're about to look at. So those are our kind of big three words. Notice I didn't really even talk about quadrants of a circle because those were defined in the quadrantal angle, 1, 2, 3, 4 quadrants, which define the positives or the negatives of our x's and y values. But unit circle, 1 unit, quadrantal angles can be determined and understood through special right triangles. Now, last week, I posted on the classroom, and right now, whether you're in period 1 or period 2, I'm just going to reference period 1's class right now because it's the first one. I posted, and you can find this right now under the Google Classroom in the section titled Classwork. We're in Module 7. I'm going to go to this thing that says trigonometric bundle. I've referenced it a few times before if you've been in previous classes, but I want to go back to it again, specifically for this yellow chapter 12 trigonometric functions slideshow. These are all, again, PowerPoints that I created for a previous school that I worked at, but they are super applicable. They follow through right into this whole trigonometric functions because it is the same material just from a different pacing of a book. But all right, as it loads, the main reason why I want to talk about it is because I'm going to basically steal a few of these slides today and go into it in notes. I want to mention that these notes are available for you on the Google Classroom. They're accessible and they're accessories to the text that we're using. So come back and take a look at these, specifically like the slides in the 50s as it relates to today's lesson. So that's just where we can find those notes, those extra notes. Now let's take a look at what they actually look like. Today's lesson is basically saying, all right, cool, we have this humongous unit circle, but we've never dealt or defined where these ordered pairs came from before. All of these things that I'm circling in orange right now, we basically haven't even discussed at all. All that we've talked about at this point are the radians in red, the distances around the circle, and the degrees being highlighted in blue, okay? Again, distances of an angle. But now I want to focus in on how those orange values get made, and I'm not going to spend too much time on it today, but I want to tell you basically how they were incepted or created through the use of basic right triangles or special right triangles, 45, 45, 90 right triangles, boom, and 30, 60, 90 right triangles. We're going to do a quick rundown and show you how we can use these two things on the right, these triangles, to create these ordered pairs. So first and foremost, we're going to just jam through this, and then we'll get to the assignment today, and we'll crush through that real quick. All right, keep in mind, y'all, that a unit circle always has a radius of 1, hence why we call it a unit circle. So if we start at the origin 0, 0, and I was to move across the radius, that would mean that this thing right here has a radius of, let's make that a little bit smaller. Sorry about that. That distance is 1 unit. That's 1 unit right there. Okay, so what that means is if I basically wanted to go to this point here, theoretically, there's 2 things happening for my center. I went across, I went over to the right, and I went up. So we call that x and y when we think about moving side to side, to the right or to the left is my x value, and moving up or down is my y value. So really what comes into play is this ordered pair is basically saying the following. I went root 2 over 2 units to the right, and I went root 2 over 2 units up. Okay, that's what that ordered pair is saying. Hey, you went root 2 over 2, which by the way, root 2 is like 1.4. So like 1.4 over 2 or 0.7 units to the right, and like approximately 0.7 units up gives us to a 45-degree angle with a radius of 1. Makes sense because when we think about right triangles, the biggest side is always the hypotenuse. 1 is bigger than 0.7 and 0.7, solid, it checks out logically. But the way that we get this information and it's foolproof is actually through the use of the special right triangle that we see in the top right-hand corner here. Because keep in mind, y'all, that we know if this is a 45-degree angle, well, then what I've really just created is the ability to make a, well, sorry about that, a 45, 45, 90 triangle. Because as I kind of get a little smaller here, and I know it's getting crazy, but this is 45 degrees. If you go straight to the right and then straight up, well, that would have to be a 90 degree, and that would have to make this last angle 45 degrees, because 45 plus 90 is 135, which leaves only 45 angles left. So inherently a 45-degree angle that goes over to the right and then jets up creates a 45, 45, 90 triangle. Now we know every single radius of a unit circle is 1. So what that really means is, hey, this is my radius right here, that distance across. So that's unit of 1. So really on our ratio here of x to x root 2, flashback to geometry, kind of remember that. Again, don't stress the memorization of these ratios. You can always find those anywhere, specifically on the notes, which I'll be uploading this picture to our notes today. Effectively, this here is our radius. It's the hypotenuse and the radius of this triangle in relation to the circle. And we know the radius is always 1. So we can define what x is equal to, aka legs. We can figure out what x is equal to by isolating x over here. What is happening to x here? It's being multiplied by root 2, so I can divide both sides by root 2. Boom, boom. X is now equal to 1 over the square root of 2. Flashback to our whole lesson on radicals. We rationalize the denominator. We get rid of the square root in the denominator by multiplying by itself in fraction form, root 2 over root 2. And then we see that x is really the same thing as root 2 over, and again, root 2, 1 times root 2 over root 2 times root 2, or 2, which, by the way, kind of take a look here, and I know it's getting crazy with these colors, but that x value was root 2 over root 2. So if we think about it now, what we've really just done is we've created all of these 45 angles in that unit circle just through the practice of two things: using a special right triangle and then using our knowledge of what it means to solve for a variable by isolating it and using opposites, kind of our algebra 1/early algebra 2 skills thrown in the mix there. One more time, one last example. I'm going to do a different one. Let's go a 30-degree angle would be like here. Okay, so I'm going to draw a triangle here on the second quadrant, and I know that this is 30 degrees because of the following. To go from 180 back to 150 means I'd have to go backwards 30 degrees, which means working in a clockwise motion, I'm going 30 degrees back like that. To go from 180 to 150, I went backwards 30 degrees, which just means this is a 30-degree angle. Now notice, again, I went to the left, and then I went up. So we went to the left and to the up, so that means this is a right angle, perfect 90 degrees, which means if this is 90, that's 30. The last angle has to be 60 degrees. Has to be. So what we've done here in green is we've actually created our beloved 30, 60, 90 right triangle. Now across from the 30-degree angle is the unit x. Across from the 60-degree angle is x root 3. And across from the 90-degree angle is the ratio 2x. Keeping in mind here, y'all, that this 2x is really our radius being 1. So really what that means is 2x is equal to 1. Divide both sides by 2 to isolate x. We now know what x is equal to. It's 1/2. Which means if we know x is equal to 1/2, this theoretically should be a distance of 1/2 up. And then this should be 1/2 times root 3, or, you know, it's getting crazy with all the writing on here, root 3 over 2. So what that really means in context to our problem here is that we went root 3 over 2 to the left, chill, root 3 over 2 to the left, negative root 3 over 2, and 1/2 up, boom, there's our y value. All those ordered pairs on this unit circle are repetitions of two things: our beloved special right triangles and our algebra knowledge of what it means to isolate and solve for x, keeping in mind that our radius or our hypotenuse is always 1 unit. Hence why I said all of my hypotenuses, x root 2, 4, 45, 45, 90, and 2x equal to 1, and then solved. Last thing I want to mention, last kind of coursework. Here's those slides that I alluded to, again, on that PowerPoint, slide 50 and 51. I want to just mention two things real quick. From our knowledge of SOHCAHTOA, we can basically figure out that sines are always the y values and cosine are always the x values, okay? Sine is y, cosine is x. So as we move in a unit circle, if I say, hey, tell me what the sine of a 60-degree angle is, that just means find the y value of 60-degree angle. So all I'd have to do is cruise on up to my circle here, get rid of all this crazy writing on it, and say, all right, let's go to 60 degrees. Boom, here it is. There's a 60-degree angle. Let's go to the y value, and that's the sine of 60 degrees. The sine of 60 is equal to square root of 3 over 2, which if we use a calculator would be like approximately 1.7 over 2, or approximately like 0.85, which if you just typed sine of 60 into a calculator, you would get about that as well. But I just want to mention sine is y, cosine is x, and our unit circle coordinates are created through special right triangles. And that effectively is going to take us through today and Thursday's lesson. So and this assignment's going to start on, we're not going to do that, not going to do that. There's our unit circle. Keep in mind, y'all, that this is all posted on the Google Classroom as well. Here's page 64. Let's use this unit circle right here. Okay, we're going to use that. All right, cruising on down to page 66. The very first problem was number 1. Let's get it rocking. So number 1, they ask us to find the lengths of the sides of the right triangles below, which has a hypotenuse of 1. Keep in mind that it makes sense that it has a hypotenuse of 1 because that's our radius. That's our unit circle radius, 1 unit. Sweet. So we want to basically find y value. Why am I calling it the y value? Because imagine if this was on a coordinate, or in a coordinate plane rather, the height would be the y, and thus the horizontal would be the x. So number 1, can we figure out the x and the y of this? No doubt, because we know our knowledge of 30, 60, 90 right triangle tells us the following. If we have a 30, 60, 90 right triangle, opposite the right angle is 2x, opposite 30 degrees is x, and opposite the 60-degree angle is x root 3. But guess what? We can now do like a little comparison here. And it seems kind of, I'm making it kind of downplay the difficulty here, but effectively what we're doing is we're comparing apples to apples here. And I'm saying, all right, let's make the hypotenuse compare it to that hypotenuse, a little proportional comparison here, and say, all right, well, if 2x is equal to 1, if the hypotenuse on a special right triangle is equal to 2x, and this hypotenuse is equal to 1, they both represent the hypotenuse of the triangle, we can figure out what x is equal to. And x is equal to 1/2. So in this case, this is where it's going to be a little bit confusing, because notice on my 30, 60, 90 right triangle, my x is here. So really what that means is what I called y, it's going to be x, so we can call whatever we want theoretically, but that's going to be equal to a height of 1/2. If my hypotenuse is 1, the side across from 30 is half of it. 1 divided by 2 or 1/2. Which means all I got to do now to figure out my length AC is take x root 3, but guess what? We now know what x is, 1/2. Boom, let's drop it in there. So instead of this x, we're going to take this value and replace it, a little substitution. 1/2 times root 3, which is equal to 1/2 times the square root of 3 over 1, so that way we have fractions. Then we do numerator times numerator. 1 times root 3 is root 3 over 2 times 1, which is 2. Boom. We just did problem number 1 right there. If you look up in a circle, you'll always see at a 30-degree angle, we have a distance across an x value of root 3 over 2, and we have a y value, a height up of 1/2. Root 3 over 2 and 1/2. All of those ordered pairs, which were previously like, what the heck, that's so much information, are really just manifestations or calculations of 30, 60, 90, 45, 45, 90 right triangles. All right, there's number 1 in the books. Okay, I'm gonna leave that up as we move on to 4, 5, 6. So again, just heads up, if you weren't aware of the page, we're on page 66. We're doing numbers 4, 5, and 6. We want to fill out the chart, specifically the coordinates, the ordered pairs, and the radians of 120-degree angle. So what we're going to do is basically just cruise on up. There's multiple ways of solving this. One way, if we were together in class, I'd really try to enforce the use of 30, 60, 90, and 45, 45, 90 right triangles and calculate it. But since we're kind of working online together, we're just going to use the unit circle here and move on up to find a 120-degree angle. So I'll cruise on up to my unit circle. 120-degree angle, we use a different color here, is right here. There's my 120-degree angle from start to finish. Now, keep in mind, they want to know radians, boom, 2 pi over 3, and ordered pair, awesome. So my ordered pair for 120-degree angle is negative 1/2, comma, root 3 over 2, and my radian was 2 pi over 3. So again, my coordinates, unfortunately that didn't work as well as I hoped. My coordinates at that point were negative 1/2, comma, root 3 over 2. And my rotation in radians was, I believe, 2 pi over 3. Cool. Same thing, we're going to reference 135-degree angle. Anything that has a 5 at the end of it in this unit circle is always going to have root 2 over 2, root 2 over 2. But since it's on the second quadrant, my x is negative. I'll just verify this for you right now. I've just been doing it over and over again. But 135-degree angle, sweet, root 2 over 2 and root 2 over 2. And my radians is 3 pi over 4. And last but not least, 150-degree angle is just going to be basically the reciprocal or the inverse of these two. Switch up the root 3 over 2 and the 1/2. Make that one negative because it's on the left side of the coordinate plane, so my x's are all negative. And this was, I believe, gosh, 150, that should be 5/6, 5 pi over 6. And again, just to verify it, see like, where the heck is he getting these numbers from? Here's my 5 pi over 6 for 150-degree angle, and my coordinate negative root 3 over 2. So we're just basically now utilizing the unit circle to show us movement in multiple ways. Degrees, classic, what we've always done. Location, which is what coordinates are, horizontal versus vertical location, and then space moved around the circle, the radian, around the crust of the pizza, so to speak. All right. No, dang, these ones are not hard because we have the unit circle. They're just going to ask us to do a couple certain things. So what we're going to probably do here is get through 11 and 12 today, y'all, and then we'll finish up this assignment on Thursday, okay? So I'll kind of adjust the pacing of this class to mirror that. But our quadrantal angles is what we started off by defining, knowing that quadrant means 4 based off the word quad. So our quadrantal angles are the 90-degree angle, which is in radians, pi over 2, a 180-degree angle, which is twice 90. So if 90 is pi over 2, well then twice that would just be pi. Our 270-degree angle, another 90 degrees past it. 270, 180 plus 90 is 270. And then this one was 3 pi over 2, if we recall correctly. And last but not least, one last 90-degree rotation gets us to 270 plus 90, or you got it, 360. Full revolution, a full circle, full spin. And that is the circumference of a circle, which keep in mind, this is our formula, 2 pi r. But since this is a unit circle, radius is always 1 unit, or 1, and anything times 1 is equal to itself. Therefore, the circumference, the distance around the whole circle, is 2 pi. There is our quadrantal angles. You could say 0 degrees up there too. All right, 45-degree angles. 45-degree angles are here, halfway between 0 and 90 is 45, halfway between 90 and 180, halfway, and the halfway marks. So all of these kind of X-looking things, almost a perfect X, make our 45-degree angles. And our 45-degree angles are repetitions of 45s. So from 0 to 45, 45 to 90, 90 plus 45 is 135. So that's why this angle over here in the second quadrant is 135. Got 180 again. I'm just adding 45. 180 plus 45 is 225. 225 plus 45 is back to that 270. 270 plus 45 is 315. And you guessed it, we're back to a full circle, 45 more degrees. Boom, let's just get rid of all these zeros. No need to have those there. All we got to do now is make our radians. So we're going to do our radians here. They asked for the coordinates, but for sake of time, we're just going to focus on radians right now. Radians are always half of the quadrants, so half of pi over 2. So if I divide pi over 2 by 2, that's the same thing as multiplying it by 1/2, which is the same thing as multiplying the denominators. 2 times 2 is 4. Okay, effectively every single 45-degree radian is always going to have a denominator of 4, which is why this one is 3/4, 5/4, and 7/4 of pi. Those are our radian measures that relate to the degrees. So that's basically going to take us to the end of our time today. Again, it's been a crazy last 2 weeks where we've been really seeing this trig in a sense of circular movement, but we're starting to really finish and finalize our knowledge of how angles can, through rotation, create this unit circle, and thus hopefully now it's starting to at least become familiar with what all these numbers and values on here mean in terms of angles, radians, and now coordinate is location. Please use these notes, reference back to the unit circle whenever you're completing anything with the unit circle. I'm totally cool with it. I just want us to become familiar and comfortable with it. So on that note, we're going to pretty much call it for class today. As always, I do appreciate y'all being here. If you have any questions, stick around. If not, we're going to finish the rest of this homework at the beginning of class on Thursday. And I look forward to seeing y'all tomorrow safely and distantly, but enjoy the outdoors. Goodbye, everybody. I appreciate y'all being here. Stick around if you have any questions. If not, see you on Thursday.
Thank you, Mr. Benham.
You're welcome. Have a great rest of your day. I appreciate you being here. Anyone have any questions before I end the meeting? Alrighty, have a great day, everyone. I appreciate y'all being here.